Okay, let's take a moment, just a short video, to talk about three variable systems. The idea is maybe watch this video a couple times, since it will be short, and get the hang of simply just solving these questions on the screen now. So, three variable systems, the strategy is make it a two variable system, because we know how to solve those. And the quickest way, in my opinion, to do that for most problems is to solve for a variable in one of the three equations. So with this very first guy, we already have a solved equation for one of the variables, x. From that point, you can take the other two and substitute. So I'll leave a big space for x because I want that to go away and become x, y's, and z's. So I will leave a space, and then I will come in with the x written in a different way. So now I have a system of these two equations of two variables, which I know how to solve those. But first, let's go ahead and write it as simple as we can so we can actually make a move here. So this is just distributing in this step. Notice how I'm keeping the equations linked together. This will help a lot in organizing because these problems take a lot of writing. So I just distributed. Now I'm going to combine like terms. So you can see that minus 4y minus y is minus 5y. And you just do that 4 times until you have your equation in simplest form. I made a little mistake. This should be a minus. Okay. Now that you have these two equations, we want to solve it just like before. So I can almost just scroll up here and pretend like this is a brand new question. The way that we solved these was with substitution or elimination. And right now, elimination is looking really nice because if I add down, I eliminate my z's completely. And I can solve this equation just like that. To find the other variable, you have to work backwards. So since looking back up on my work, the closest variable I had was z. So I'm going to use this equation. I could also use this one. I'm going to use the second one since it's been untouched. And plug back in what y is. So this is like a back substitute sort of thing. And what it does is it allows us to solve for z. So z is 3. And once you have that system solved, we zoom back out and notice that, hey, there was also x involved. And if you work it out this way, and the way I'm showing you, you can just go back to your first boxed in equation that was solved for x. And then you just got to plug in z. And we get that x is 11. Okay, so we have all three variables solved for. Okay, let's take a look at this one. So same type of strategy. The strategy last time, if you look, was solve for a variable. Step 1, we did that, got x. We substitute that in green. We found the other, and we simplified that, and that gave us a system, this one. And then we solve that like we know how, and then we substitute back those two values into the original. So to get me started on this next one, I got to solve for one of the variables. I got to do step 1. So when I look at these three equations, my eyes first go to the last one because it doesn't have a number on the right. It's just 0. So in terms of a substitution equation, I'm thinking that this one will be easiest for us to work with. So y, I could also solve for z if I wanted to, but I want to solve this for y, and this is going to be the equation that I box in. You could have solved for x up here if you wanted to. I want to choose, so I have two things here. I want to try and minimize that. If you didn't use the last equation, you'd have three things there, and that just makes for a worse substitution down the line. So now is the time to substitute in what y is. So give me a moment. I'm just going to copy down the equations, leaving a space for y. So y is minus 2x minus z. Okay. I'll use my first step to distribute. So the first one doesn't need any distributing. It's just distributing plus 1. So I'm fine with just omitting the parentheses. And we'll keep going here. So there's a lot of algebra to work through here and a lot of places for mistakes. So we need to be careful, and I need to be careful too. First equation, I got x minus 2x. That's minus x. I have minus z plus 2z. That should be plus z. So that's looking very good. Next equation, I have 6x plus 3z equals minus 9. Okay, let's just take a moment and make sure that everything looks correct. Yeah, I think so. So how are we going to then solve this two-variable system? This is the goal. That was the goal. Get a two-variable system, and now we just need to solve this for x and z. So personally, the elimination method is not as clear for this one. There's no matching powers. Substitution, though, could be a lot. I'm going to try maybe to multiply the first equation by something so I get elimination happening. I see I have a minus sign and a plus sign. We got opposites, so maybe if I multiply this top equation by 6, let's go ahead and do that. And I still have my other equation. Cool. Now I can just add down 0 plus 9z equals minus 45. That looks good. So z is minus 5. Zooming or going back and zooming out and looking back at what we've done, this was one of our original two-variable equations. I can use that, so this down here, and put in what z was and solve for x. So x is 1. And then all that's left to do is take our very original equation and plug back in what we learned is x and what we learned was z. So it looks like y equals 3. Okay? And we could verify this by plugging it into each one of these equations and making sure that it works. And yes, you have to do every single equation. So, but I'll just show you one. So if I did want to check, you have to write down, let's check the bottom equation is probably correct. let's check the top equation. So we want to know, is this true based on the numbers we got? And if you do plug them in carefully, we want to test, is this minus 6? Well, I think 4 minus 10 is minus 6. So we would have to check all three if you really wanted to. But if you feel confident you get whole numbers, then it's likely that you did it correct. Cool. So this problem below can be done with 3 variable systems, but I want to encourage you guys to solve questions like this one on your own with maybe a guess and check method, because we don't always want to go to writing out 3, 4, 5 equations when we can just do this with mentally or with a picture. So I have quarters, nickels, and dimes in my pocket. I have 9 coins. I have twice the amount of quarters than nickels, and I also have $1.40. So those are 3 sentences, 3 equations. How many coins do I have of each type? So pause the video, take 3 or 4 minutes, and see if you can come up with an answer by just trying to guess and check your way through this. All right, so the most limiting part of this, I think, is the fact that our combination has to have twice the amount of quarters than nickels. Because if I'm imagining that means we either have 1 nickel and 2 quarters and the rest dimes. We have 2 nickels and 4 quarters. Or we have 3 nickels and 6 quarters, which that's borderline too many, because we can only have 9 coins, and this is a lot more than $1.50. So that, or $1.40. It's $1.50 plus 15 cents. So that's too much. And we could also have 0 nickels and 0 quarters. You see, so I'm using this one equation to kind of establish the different cases I have. So it's either going to be this one or this one. I'm not sure which. To be sure, let's fill in what the other coins are. The only other currency here are dimes. So there's going to be 6 dimes. And how much money is here in this example? Well, there's 60 cents in dimes, 50 cents in quarters. That's $1.10, but then we have to add the nickel. So this is $1.15. That's too much. So it must be the case then that we have 2 nickels, 4 quarters, and 3 dimes. Because if we do add all this together, so this was not right. If we add this together, we get $1 in quarters and 40 cents in the other stuff. So it turns out that it's this combination that makes everything correct. If you were able to get that, great. If not, kind of pull what you can from this example. We could also set up 3 different equations for this. And I encourage you to look at the key to see how I've done that. And also, you can take a look at this challenge on the key as well. I'm not going to test you over this, but it gives you an idea of what 3 variables really means. But yeah, so make sure you understand how these 2 systems were solved. And of course, I'm here to answer any questions you have about